Hi, welcome back to my channel. Today I'm going to talk about Java wildcards and bounds. Bounds has been categorized into two formats, upper bound and lower bound. Let's jump in. So as I said, I'm using Java as the language to do the labs. So what is a wildcard? Wildcard is something of the object type unknown. So there you will use a wildcard and you have a subtype that you know that okay, what is the subtype? Say if I'm defining a object of parent, if child is being derived from the parent, so I know parent class is the object and that has been derived by the child class. Let us consider that integer is object which is of a subtype of number. This is perfectly valid. Now think of list integer of a generic type is not subtype of list number. Very, very important thing which you should know as a developer. If you do not know, then it is very hard to assign the objects of different types. Okay. These two are not related, but these two are related. That's the you know major concept which we are talking. This was basically introduced in Java 1.5 version. Okay, to define the similar type of a list generic type, we will use a wildcard representation. List number and list integer, the common parent type is the wildcard list question mark. So the same where you can see it, list generic type of wildcard, list number you can have or list integer. What is a bound? Bound is something limited. So what kind of object you wanted to limit during development and application, we will be significantly specifying it. How do we define the bounds? To define a bounds, basically we use Java generics. That is the diamond notion where we use. Okay. So as I discussed in the previous slide, integer is derived from the number class where you will get all the features of the number. So number can hold either float or integer, but integer significantly it holds only the integer. As I said, this diamond notation was introduced in Java 5. Why I am bringing this concept today? Java 8 language is heavily depends on this upper and lower bounds. I will show you how basically has been implemented. As I said, upper bound. Say if I wanted to store a list of floating point numbers, a list of integer numbers to a generic type, definitely it is possible. How do you handle these things? We use two types of keywords. One is extends keyword to define a upper bound. Super keyword used to define a lower bound. So let me show you the sample example here. List the generic type wildcard extends number. AA is the object reference. Is a top level upper bound. List of question mark extends integer. The another type of upper bound. Now I am defining list integer CC. Whenever I create list of integer numbers, I can assign to AA. BB also I can assign. AA equal to BB because this is a super type. This is how in terms of a generic upper bound way of assigning the objects. It is not something similar to the standard inheritance. Okay, now see it. List of integer, basically you can assign it to its parent. Way of defining, that is the key fundamental which we need to understand. Question mark extends integer, that also you can assign it to its parent class in terms of a boundary level, not standard inheritance concept here. Okay. So now the same thing I'm defining list of question mark super integer AA. This is how you will be defining a lower bound. List of question mark super number BB. List of number CC. Now you look at the syntax quite in the reverse way which is being assigning. That is how basically the lower bound and upper bounds are defined. Extends is the keyword with the generic signature to define the upper bound. To define the lower bound with super keyword along with the generic notation. So now if you assign BB equal to AA, definitely it is not bound. You will get a compile time error. The same case BB equal to AA because it is not upper bound. That's the reason here lower bound will give a compile time error because this is quite opposite direction of the lower bound upper bound defining things. Super is the keyword to define lower bound, upper is the upper bound definition to be defined with a generic extend keyword. So prerequisites Java 5, I'm using Java 18. You can choose your own IDE. Now let's try to do the hands-on session. So here I'm going to create a new package. This code is available in the internet, GitHub. I'll show you at the last. So not the class, I'm going to define a package, problems and solve 8 to do the exercise. So I'm defining a Java class, Java generics, the name of the class which I'm defining. So I'm going to add it. So I'm going to create a simple main driver where we can easily test all these things. List. As I was talking about you, that integer, I'm defining cc equal to new array list where I'm going to store some numbers. So cc dot add say 10, cc dot add 20. Okay, I have stored a couple of integer numbers. Now I define the next upper bound with a wildcard extends integer. I will define the next level upper bound extends number. So this I define it as baby, this I define it as a. Okay. Now my objects structures are ready. Now kindly look at it. A equal to bb. So you can use and you can print a. This bb equal to cc. I can print that will successfully printed bb. Now I will try to show you cc equal to a. It's a compile time error because required type of integer but it is capturing it. That is what I was talking. So now let me go ahead and run this program. Hope this is how you define whenever defining upper bounds. So this is taking little time. Just allow me some time. It is real world, maybe some compilation problem. Something changed. That is the reason it is showing. Module 18, 18. The project is 18. Fine. Okay. Now let's run it. So definitely you can go ahead and try at your side. You will be delighted to learn these are very crucial in Java 8. So just it takes time to build the indexes by the IDE. So meantime, let's write the lower bounds. List super integer, say C1 new or a list. Let us do copy paste. Because bb is no value, that's why it is empty. bb, if you look at it, you will see that. So you can say it a equal to bb. Okay, now let us define question mark number then number. This is how do you define the number. b1, this is a1. Okay, so let me rerun the same program. Now you will see a also gets printed with the value for the upper bound. Okay, so now I'm defining c1 equal to b1, perfectly valid. c1 equal to a1 as well, but a1 equal to c1 strictly a compile time error. So that means I'm defining a1 dot add. I'm going to add 10. So now I am assigning c1 to s out c1 b1 dot add 20. Now let me print it. b1, you can put statements according to printing. So because we are assigning both, so this is definitely, as I said, this is how the lower bound declaration where you can define it. Okay, so it is a compile time error. Now let's go ahead and run it. So this is a sample exercise. So you will be defining upper bound. Now let us talk about how it is being defined. Functional interface. You know all maybe using function is the functional interface from the Java 8. Array operator. Let us consider function. Okay, the functional interface. Just showing it. You will see the input type of object any type, the return type. Here it is an apply operation, but if you look at the default operations, all are following. This is the lower bound followed by the upper bound. So that is the reason I was advising all the functional interfaces, you will see it. Lower bound is the first, followed by the upper bound. Hope this makes you clear why I am giving you this particular demonstration for the real-time Java generics, how important, how much valuable you're supposed to understand the wildcard and followed by the bounds, upper or lower bound. Okay, so that's all for today lab. I hope you understood Java generics, how to define a wildcard and then followed by the Java generics, upper bound, lower bound. Okay, thank you for watching. Please like it, comment it, subscribe it, and share it with your friends.